All right, welcome back everyone for another deep dive. And today we're really tackling something that's pretty mind-blowing, I think, at least for me. Large language models. We hear about them all the time now. They're kind of everywhere. But what are they really all about? These AI systems that can just process so much information and create text that sounds like it was written by a human.
Yeah, they're pretty amazing. They're built on these huge data sets, just mountains of information, and they use some really complex technology, things like transformer architectures, deep learning, all those buzzwords you hear about. And they can do so much, like you said, answer your questions, summarize complex topics, even write different kinds of creative content.
Yeah, it's wild. And it makes you wonder, with all that power, are there any limitations? I mean, we
Right.
humans, we have our blind spots, right? We get stuck in our ways of thinking sometimes. Could LLMs have similar issues?
That's a great question, and it's exactly what we're going to explore today. Since LLMs learn by finding patterns in all that data they're trained on, could they also fall prey to the same cognitive biases that we humans do?
Right, because we're basically feeding them all of our own human thinking, good and bad.
Right.
Right. And in this deep dive, we're focusing on one specific cognitive bias, the Einstellung effect.
Yeah, the Einstellung effect.
And I love that word, Einstellung. It's German, right?
It is. It basically translates to approach or attitude or sometimes setting.
Hmm.
And it describes this tendency we have to get stuck using familiar methods to solve new problems, even when there might be a better, simpler way.
Right, like you've got your trusty toolbox, you always reach for the same hammer, even if you need a screwdriver for the job.
Exactly. You're so used to doing things one way, it becomes almost automatic. And it's not just about stubbornness or habit, it's actually a fundamental aspect of how our brains work, how we learn and adapt.
And there are all these related concepts too, right? Like
Yeah.
functional fixedness.
Right, where you can only see an object serving its usual purpose. You mentioned the hammer earlier. That's a perfect example.
Yeah. Or a mental set where you keep using the same strategy because it worked before. But then you get blind to new possibilities. And this isn't just some quirky human thing, right?
Mhm.
As LLMs become more integrated into important fields like medicine or finance, we really need to understand if they share this tendency.
Absolutely. Imagine an AI medical diagnosis tool that gets stuck on a familiar pattern of symptoms and it misses a rare disease just because it doesn't fit the usual mold.
Yeah, or an AI financial advisor recommending the same tired investment strategy that worked in the past but is now totally outdated.
Exactly. So, in this deep dive, we're really going to unpack this whole idea. Can these advanced AI systems get stuck in a rut like we do? What's the evidence? What are the implications? What can we do about it?
All right, so let's start at the beginning. How did we even discover this getting stuck phenomenon in humans?
Well, the classic example is a study done by Abraham Lutyens way back in the 1940s. He came up with these water jar problems. Like you have three jars, different sizes.
Okay, I think I've seen those, like puzzles, right?
Exactly. And your goal is to measure out a specific amount of water using only those three jars.
Right, so you might have like a 10-liter jar, a 7-liter jar, and a 3-liter jar, and you have to figure out how to get exactly, say, 5 liters.
Precisely. And Lutyens gave people a bunch of these problems in a row, and they could all be solved using the same kind of complicated method. Then he snuck in a problem that could still be solved with that method, but there was also a much simpler, faster way to do it.
That was sneaky. And did people notice the shortcut?
Many didn't. They just kept using the longer, more familiar method from the previous problems. Their brains were basically primed to use that approach. They were in that Einstellung, that mental set.
Wow, so they were so focused on what worked before, they completely missed the easier solution. It's almost like they couldn't see it, even though it was right there.
Yeah, and it gets even more interesting. When Lutyens gave them a final problem that couldn't be solved with that old method, many just gave up. They said it was impossible instead of even trying a different approach.
So their past success actually blocked them from finding any solution at all. It makes you think, could LLMs have the same issue? Could their training create a similar kind of mental block?
That's the big question. And the thing is, this Einstein effect isn't just limited to these puzzle scenarios. It shows up all over the place, even in experts.
Right, you mentioned medicine and chess earlier. Like, how does this mental rut affect doctors and chess grandmasters?
Well, with doctors, imagine a doctor who's seen hundreds of patients with the flu. They get really good at recognizing the typical symptoms.
Right, so they're seeing patterns, making connections.
Exactly. But then a patient comes in with slightly unusual symptoms, maybe something rare, but the doctor might still try to fit it into that familiar flu diagnosis because that's what they're used to. That's their Einstellung.
So they might miss those subtle clues that point to something else entirely.
Exactly. And with chess, it's kind of similar. You have these grandmasters who have played thousands of games. They've seen countless board positions. So when they encounter a familiar setup, their brain automatically activates those well-worn patterns, those strategies that have worked in the past.
Right, they're mental shortcuts.
Yeah, but sometimes those shortcuts lead them astray. They might overlook a brilliant, unconventional move because it doesn't fit their established patterns.
So even experts, with all their knowledge and experience, can get tripped up by this Einstellung effect.
Mm,
It's almost like our brains are too good at finding patterns sometimes.
right, our brains are wired for efficiency. We're constantly looking for shortcuts, ways to save mental energy, and most of the time, that's a good thing. But sometimes it leads us down the wrong path.
So what's actually happening in our minds when we get stuck in this rut? What are the underlying mechanisms?
Well, one factor is inductive reasoning. We learn from experience, right? So we see something happen a few times, and we start to assume it's a general rule. Like, if a certain approach worked before, it must always work.
Right, it's like we're creating our own little theories based on limited data.
Exactly. And then there's synaptic plasticity. This is how our brains physically change as we learn. When we use a particular pathway in our brain repeatedly, the connections between neurons get stronger. So the more we use a specific strategy, the more ingrained it becomes in our brain.
It's like building a mental highway. The more you travel that route, the smoother and wider it gets.
Exactly. And then there's attentional bias. When we're faced with a new problem, our attention naturally gravitates towards the familiar, the things we've seen before.
So we're primed to see what we expect to see.
Right. And finally, there are those problem-solving heuristics we talked about earlier, those mental shortcuts that we develop based on our past experience. They help us make quick decisions, but they can also make us blind to new possibilities.
So we have all these built-in mechanisms that can make us prone to the Einstellung effect.
Mm.
And now the question is, do LLMs share these vulnerabilities? They're learning from us after all.
Yeah, let's get into how LLMs actually work and see where the potential pitfalls might be.
Okay, so under the hood, what's going on with these LLMs?
Well, most of them are built using these things called transformer networks. And these networks are kind of like complex information processing systems with different parts. There are encoders that break down the input text, decoders that build the output text, and then there's this really crucial thing called the self-attention mechanism.
Self-attention. It sounds like the AI is looking in the mirror or something.
It's kind of like that. It's basically the AI constantly checking in with itself, figuring out which parts of the text are most important for understanding the meaning. So it's not just processing words one after another, it's building these rich connections between different parts of the text, even across long distances.
So it's kind of like how we read, right? We don't just focus on each word individually. We're always connecting it to what came before and what we think might come next.
Exactly. And these models are huge. I mean, billions, even trillions of parameters. Think of these parameters like tiny little knobs that the AI can adjust to fine-tune its understanding of the world. And the data they learn from is equally massive. Imagine reading every book in the Library of Congress, plus everything on the internet, several times over. That's the kind of scale we're talking about.
It makes my head spin just thinking about it.
It's mind-boggling. And during this training process, the LLM is basically soaking up all these patterns in the data. It's learning which words tend to go together, what kinds of phrases are common, what kind of logic and reasoning people use. And this ability to learn patterns is what makes LLMs so powerful. But it also means they're highly influenced by whatever is most common or prominent in their training data.
Right. So if they see a certain type of problem solved a certain way over and over again, they might get really good at that specific approach. But then what happens when they encounter a slightly different problem that requires a new way of thinking?
That's the crux of it, and it's where the potential for the Einstellung effect comes in. Now, LLMs have shown some really impressive abilities. They can understand and generate language really well, sometimes even rivaling humans on certain tasks. They can hold complex ideas in their minds, make inferences, even adapt their style based on how you prompt them.
Right, like if you ask it to write a poem in the style of Shakespeare, it can do a pretty good job.
Exactly. But they do have limitations. They're not so good at true causal reasoning, understanding the why behind things, and they can struggle with planning or abstract thought. And importantly, recent research has shown they can have trouble generalizing to new situations. They might get stuck applying familiar patterns even when they don't fit.
And you mentioned this before, this tendency for LLMs to be overconfident in wrong answers. It's kind of unsettling, like they don't know what they don't know.
Yeah, That's a big concern. They might sound very convincing, but their logic might be completely off. And it's these limitations, this heavy reliance on pattern matching, memorization, and sometimes lack of flexibility that makes us wonder if they could be susceptible to the Einstellung effect. Just like humans, they might get stuck in a mental rut even when a better solution is available.
All right, so we've laid out the case for why LLMs might be vulnerable to this bias. Now let's look at the evidence. What kind of research has actually been done to test this?
Well, there have been some really interesting studies recently. One that's really relevant uses this thing called the Medical Abstraction and Reasoning Corpus, or MARC for short. It's a data set specifically designed to assess clinical reasoning in LLMs.
Okay, so like medical AI diagnosing patients.
Exactly. But the clever thing about MARC is that it's designed to try and trigger the Einstellung effect.
How does it do that?
So the questions in MARC are kind of like those you'd see on the U.S. medical licensing exam. They're realistic medical scenarios, but they're crafted in a way that makes it difficult for LLMs to just rely on simple pattern matching. They often present familiar medical situations, but with subtle twists or variations.
Oh, so like a patient might have symptoms that look like a common cold, but it's actually something rarer.
Right. The most obvious answer might be there, the one that fits the familiar pattern, but the correct answer requires more careful reasoning, digging deeper into the specifics of the case. It's like a trap to see if the LLM will fall for the familiar but ultimately wrong solution.
So it's testing if the LLM can break free from its training, its Einstellung.
Mhm.
And what were the results? Did the LLMs pass the test?
Well, unfortunately, they didn't do so well. Compared to human doctors, even some of the most advanced LLMs perform surprisingly poorly on MARC. They often seem to lack that common sense reasoning that doctors use, and they even made up information that wasn't in the patient's case.
Wait, made up information? Like hallucinations?
Exactly. And this poor performance really suggests that the LLMs were relying too heavily on those familiar patterns they learned during training. Instead of really thinking through the problem, they got stuck in that pattern matching mode and missed the subtle clues. And what's even more worrying, they were often very confident in their wrong answers.
Oh, that's not good.
Yeah.
Especially if we're thinking about using these LLMs in real medical settings.
Yeah, it highlights the potential risks of relying on AI that might be prone to these kinds of biases. And this hallucination phenomenon, where the LLM confidently makes stuff up, could actually be a manifestation of the Einstellung effect. It's like the model is so fixated on a familiar medical pattern that it forces the information to fit, even if it means inventing details.
Okay, so we've seen how the Einstellung effect might show up in medical reasoning. What about more creative problem solving, something that requires thinking outside the box?
There's another fascinating study that used this data set called the Only Connect Wall, or OCW. It's based on a British quiz show where contestants have to find connections between seemingly random words.
Oh, I've seen that show. It's like a giant word puzzle, right?
Exactly. And the OCW dataset is basically a collection of these word puzzles. You have a wall of clue words, and you have to sort them into groups based on some hidden connection. But here's the catch. They included red herrings, misleading clues that could fit into multiple categories.
So it's like they're deliberately trying to trick the LLMs, see if they get lured into the wrong path?
Precisely. It's testing whether the LLMs can resist those tempting but ultimately incorrect associations and find the true connections. And the results showed that, yeah, LLMs can be susceptible to this kind of misleading information. They sometimes fixate on a familiar connection based on their training data, even when it doesn't quite fit the overall puzzle.
So it's like they're seeing what they want to see, what they're used to seeing, instead of looking at the bigger picture.
Exactly. And there's also been research looking at how the Einstellung effect might affect mathematical reasoning in LLMs. They've used data sets with different kinds of math problems, some that are more complex and require multiple steps, and others that have a simple shortcut solution.
Okay, so like one problem might take 5 steps to solve, but another one, you could just use a simple formula.
Right. And the researchers manipulated the order in which they presented these problems to the LLMs. They might give them a bunch of complex problems first, which could create a mental set for using those longer multi-step approaches. Then they'd sneak in a shortcut problem to see if the LLM would recognize and use the simpler solution, or if they'd stick to their old habits.
Oh, so kind of like those water jar experiments we talked about earlier.
Yeah.
It's the same principle, trying to induce a mental set through experience.
Exactly. And they also tried different prompting techniques to see if they could nudge the LLMs towards more flexible thinking. like giving them a few examples of how to solve similar problems or encouraging them to explain their reasoning step by step.
So kind of like giving them hints, showing them different ways to approach the problem.
Right. And the overall findings suggest that LLMs do exhibit this kind of cognitive rigidity in math. They can get stuck using a familiar method even when a much simpler solution exists. It's further evidence for the potential for the Einstellung effect in their reasoning processes.
Okay, so we're seeing this pattern emerge across different types of reasoning, medical, creative problem solving, and mathematical. And you mentioned earlier that the training data might play a big role in this. Can you elaborate on that?
Yeah, the training data is absolutely crucial. Remember, LLMs learn from massive amounts of text and code from the internet. And this data reflects all sorts of human biases, including the way we document and explain problem-solving approaches.
Right, like if most online tutorials for a particular programming task use a certain library, the LLM might learn to always recommend that library, even if there are better options.
Exactly. And this overrepresentation of certain approaches in the training data can create a kind of cognitive bias in the LLM. It's like they develop a preference for certain methods because they've seen them so often.
So it's like a self-fulfilling prophecy. The more they see a certain approach, the more likely they are to use it in the future, even if it's not the best approach.
Exactly. And this can also contribute to those hallucinations we talked about earlier. If a wrong pattern is strongly embedded in the training data, the LLM might confidently generate a factually incorrect answer that aligns with that familiar but wrong pattern.
So the very thing that makes LLMs so powerful, their ability to learn from massive amounts of data, can also be their Achilles heel when it comes to avoiding these cognitive biases.
It's a real challenge. The training data is both the source of their incredible abilities and a potential source of these limitations.
Okay, so we've established that the Einstellung effect is a real concern for LLMs, and we're starting to understand why. Now let's shift gears and talk about the implications. Why does this all matter in the real world? What are the potential consequences?
Well, there are several big concerns. One is that it could really stifle creativity and innovation in LLMs. If they're always relying on familiar patterns, they might struggle to come up with truly novel solutions. Imagine using LLMs to help with scientific discovery. If they're stuck in those old ways of thinking, they might miss those breakthrough insights that come from challenging assumptions and exploring new approaches.
So they might be good at solving problems we already know how to solve, but not so good at pushing the boundaries of knowledge.
Exactly. And another concern is adaptability. The real world is messy and unpredictable. There are always new challenges, new situations that don't fit neatly into the patterns LLMs have seen before. If they can't adapt, they might not be very helpful in those situations.
Right, like imagine an LLM that's been trained on data from before the pandemic. It might not be able to give very useful advice in a post-pandemic world.
Exactly. And this inflexibility could even have broader implications. Imagine entire teams or organizations becoming reliant on AI that's prone to the Einstellung effect. It could lead to a kind of stagnation, a resistance to new ideas and methods.
It's like a collective mental rut.
Exactly. And finally, there's the risk that we might become too complacent, too reliant on those good enough solutions from LLMs. If they can quickly generate a plausible answer, we might just accept it without questioning it or exploring other possibilities. And over time, this could actually make us less effective thinkers ourselves.
Yeah, it's like we're outsourcing our critical thinking skills to the AI. And
Yeah.
if the AI is biased, then our thinking becomes biased too. All right, so it's clear that we need to address this Einstellung effect in LLMs. The big question is, what can we actually do about it?
Well, there are several promising avenues that researchers are exploring. One area is advanced prompting techniques. We talked a bit about these before. Things like chain of thought prompting, where you guide the LLM to break down a problem step by step, or tree of thought prompting, where you encourage it to explore multiple possibilities.
So it's like giving the LLM a set of instructions to help it think more systematically and avoid jumping to conclusions.
Exactly. There's also reflection prompting, where you ask the LLM to evaluate its own answers and reasoning, and step back prompting, where you encourage it to consider the broader context before diving into specifics.
So it's all about providing the LLM with more structure and guidance, helping it to be more deliberate and thoughtful. What about the training process itself? Can we train LLMs in a way that makes them less susceptible to the Einstellung effect?
Yeah, that's a big area of focus. One approach is to fine-tune LLMs on data sets that specifically include those tricky situations where familiar solutions fail and creative solutions are required. This helps them learn that those old patterns don't always work.
So it's like giving them a crash course in thinking outside the box.
Exactly. And another promising approach is reinforcement learning with human feedback. This is where you train the LLM to not only get the right answer, but also to do it in a way that avoids those biased patterns. It's like rewarding them for being creative and flexible.
So we're not just teaching them what to think, we're teaching them how to think.
Precisely. And finally, we need better ways to actually evaluate LLMs to see if these mitigation strategies are working. That's where those specialized benchmarks, like the MARC and the Only Connect wall, become really important. They're designed to test for cognitive flexibility, not just accuracy.
Right, it's not just about getting the right answer, it's about getting the right answer in the right way.
Exactly. And we need more of these kinds of benchmarks across different domains so we can get a comprehensive picture of how adaptable and flexible LLMs really are.
Okay, so it sounds like we need a multifaceted approach, combining clever prompting, targeted training, and rigorous evaluation. And it's an ongoing effort. We're still learning about these LLMs and how to make them more robust and reliable.
Absolutely. It's a fascinating area of research.
All right, so to wrap up our deep dive, what are your key takeaways? What should our listeners keep in mind about the Einstellung effect in LLMs?
Well, the main point is that current research suggests that LLMs are indeed vulnerable to this cognitive bias. They can get stuck in those mental ruts just like humans can. And this has significant implications for how we use them and how much we can rely on them.
Right, we can't just assume that they're always going to give us the best or most creative solution. We have to be aware of their limitations and use them thoughtfully.
Exactly. And the good news is that there are promising strategies for mitigating the Einstellung effect in LLMs. We can use clever prompting, train them in new ways, and develop better evaluation methods.
So there's hope for the future. We can make these LLMs more flexible and adaptable.
All right, well, thank you so much for joining us for this deep dive. It's been a really illuminating conversation. And for our listeners, as you go about your day and encounter these increasingly powerful AI systems, think about this. How might an awareness of their potential for bias, for getting stuck in those familiar patterns, change how you interact with them? How can we encourage these LLMs to be more creative, more adaptable, more truly intelligent? That's something to ponder until our next deep dive.